Alright, I'm going to try to do this just with some sound here. This is the old legacy Java version of the PhET simulator making waves. And this one will show a lot of what I showed in the Falstad video. For example, the triangle recipe is here. You can see that we get a triangle out, and a number of those. Right. What I like about this one is that you can type any amplitude for the component waves that you want. So the fundamental would go here, the second harmonic, the third, the fourth, and all of those you can customize. Fix that. Okay. So maybe this is a way you can see how the addition works. In this middle window shows you all the harmonics individually with different colors, and you can change the scale if you like. And then the sum of all of those waves goes into the sum graphic. So I can zoom out a bit. I mean, we're adding quite a few large waves here, so it's going to get very tall. You can see the pattern of this one as well. Get an idea of what happens when you add all the harmonics together with the same amplitude. And it has all the same features, the square, the sawtooth, and so on, as before. So let me just looking back here. Right, there's a sawtooth. With the saw wave, you have all of the harmonics on, and the second one is cut by half, the third one's cut by a third, and so on. I like to do this typing real quick. So 1, negative 0.5, 0.33, negative 0.25, 0.2, negative 0.16, 0.14, negative 0.12, 1, negative 0.1, 0.09, enter. Okay, so this is the mix of, if your fundamental has an amplitude 1, this is the mix that will give you the sawtooth wave. You can see that right there. And all of the different colors show the relative sizes of each one. I think I showed before. What's the number? 0, 0, 0, 0. So if you eliminate all of the odd numbered harmonics, I guess that one could stay. You get the square, like I showed before. And if you convert this to, instead of 1/3, negative 1/9, this one to positive 1/25, this one to negative 1/49. It's really ridiculous at this point. Right. That's the recipe for the triangle. You have 1/3 squared, 1/5 squared, 1/7 squared, approximately 1/9 squared. Right. So you can get the same ones. I liked this one because I was able to type in the amplitudes directly and show you what you get if you make every amplitude the same. There's another complicated addition which I just discovered on this program, where if you make like some middle frequency the highest and then mix in smaller amounts of the one around it, you get a different kind of pulse set. Kind of reminds me of some of what my one amplitude for everything was doing. Anyway, that's it for this program. I wanted you to see it, just another way it's colored. It's another perspective on the Fourier breakdown of weights. Periodic waves, we can make up the sine and cosine functions.